Hello YouTube viewers, welcome to my channel S2T. In today's show, Rocket Monday, we're gonna talk about ISRO's small satellite launch vehicle. So let's dive right into it. Well, first you have to understand what the heck we are talking about. We are talking about dedicated small satellite launch vehicle. ISRO already has a catalog of giant rockets. It's a specific rocket that is built to do one thing and one thing alone is just be a dedicated launch system for a small satellite. Now, the core game behind it, the core reason behind it is basically it's supposed to be cheap, good for your pocket. B is supposed to be quick. Quick as in like basically I called up them like bro, I want to send this satellite. They're like I got this. I'm gonna give you 1 day delivery. So that's the whole point. Again, that's an exaggeration, but you get the point. Like right now, satellites take upwards of a year to like okay book and then get the actual launch. So they want to shrink that window from that phone call to actual launch to as many days as possible. Basically, they want to take what takes years to weeks. Now, when I say small satellite, what does that exactly mean? Small satellite generally means anything below 500 kilogram. That's a scale, and generally they are aimed for what we call low Earth orbit. It's not necessary, it's not fixed, but this rocket is built for low Earth orbit, aka anything below 5,000 kilometer. And very specifically speaking, sun synchronous orbit is its primary goal. Now, sun synchronous orbit and low Earth orbit they are the same way. Only the rotational plane is tilted at 90 degree. So CubeSats are also another interesting possibility simply because CubeSats have exploded, aka 1 CubeSat simply means 10 centimeter by 10 centimeter by 10 centimeter. So and if you 3U simply means 10 centimeter by 10 centimeter by 30 centimeter. So these sort of satellites have started to explode, like they have started to gain traction in as early as like if around 2010, and now they are like very big part of our economy, so to say. So that market is growing, so people want to get into it. So these sort of CubeSats are really everywhere. Like you can see, like that's the size of a big loaf of bread. So the market is growing. Now problem with current India's rocket is basically India's this one rocket known as PSLV, and you must have heard of it simply because it has the world record of 104 satellite launches in one go. So again, we have the rocket. Problem is that's too damn expensive. Now, what's the logic behind it? Why ISRO is doing something like this? Well, the primary goal is PSLV is too expensive. It's 300 crore rupees in Indian currency, and that gives you roughly $40 million. Yes, it is more expensive than basically Saturn 5. I'm saying it's more expensive than Falcon 9, so to say. You can understand this idea that it's not that what you call lucrative. On top of that, it to launch CubeSats, basically the how to achieve that world record. This was not the main target. The target was not main break the world record. Target was like they were launching multiple satellites. It has a 10-ton capacity, so they had enough room to spare. In that room to spare, these secondary payloads were added, so to say, and doing that reduced per CubeSat cost to drastically. But you can understand, not everybody can afford that. Not everybody is like, okay, I'm gonna bulk order 100 satellites. Not everybody can do that. And many times before you want to launch hundreds of satellites, something, let's say you have a requirement where you need to launch 100 satellites, you want to launch few of them to test it out whether the heck damn thing works or not. So this is not suited for that. On top of that, let's say you have the money. Let's say you have the money to burn and you're like, I'm just gonna order this. No problem with that. Problem is another aspects comes along is like, bro, it's gonna take time. So let's say you made the phone call. Best case scenario is 6 months. Now, for many people, that's acceptable. Like for big communication satellites, that's like no big deal because those satellites last around 10 years or plus, and the CubeSats they last 2 years. So we're saying 6 months in that term, yeah, that's a big deal. So that's the logic behind it. Like it is unsuited. Basically, it's like you want a drill, and this is like a tunnel boring machine. So SSLV was created. Now it is a three-stage solid rocket system. Why solid rocket? Simply because it's cheaper, and it's gonna have a quote unquote fourth stage, which is gonna be final trimming module. Now that trimming would be just allowing to if you want to launch satellite in different inclination, and again it's untested right now, so we do not know what it can be used for. But the primary goal of that fourth stage is basically fine tune the orbits, and if like there is some you want to add spin stabilization, they can do that, and the target cost is 30 crores, which is $4.2 million. Now you can understand, now it is very cheap. However, the diameter of this puppy is huge. It's around 2 meters, which is tangibly bigger than almost any sounding rockets, almost most of the other competitors are. We're going to talk about competitors also. So you have to understand, this is a big rocket. It is around 34 meters tall. Like that's tall. That's a big tall rockets. And fairing diameters also makes this quite a capable rocket. On top of that, the total mass would be around 120 tons. So it's not a joke. It's like it's a huge baby. And that's the whole point. What ISRO is marketing as is that ISRO is not marketing it. ISRO created a subcategory, basically independent organization known as NSIL. Now that is National Space Integration System. What they're gonna do is basically they're gonna take technology from ISRO, they're gonna build the rocket, and they're gonna ask for private companies partnership. It's like, bro, do you need this technology that ISRO made? You need someone to handle the transfer of technology. This puppy is gonna handle that, and they're gonna make the small rockets. ISRO is not gonna focus on making small rocket. That will be taking attention away from expensive missions like Chandrayaan 3 and Mangalyaan 2 and all that jazz. So this exactly specific thing is built. Think of it this way: it's a low-level commercial resupply mission. So that's the main point. Multiple small satellites can be launched, and this time I'm talking like, if your satellite is 100 kilogram or less, 10 kilogram satellites, and the turnaround time, their main goal is 15 days. Basically, you say, here's my satellite, take it and go. 15 days later, it will be in the orbit. So that's the main game here. And to low Earth orbit, it's gonna send half ton, and for sun synchronous orbit is around 300 kilograms. So that's the reality of it. So what about the details about it? Like how the heck this thing is gonna work? Now, to reduce the cost, the primary alloy that is made for chassis and everything is 2014 aluminum alloy. It's not made in 2014. It's just a specific number they came up with. Now that aluminum alloy is relatively cheap. It's something tested, time tested. This is not untested material. It's tested, it's cheap. So we're gonna use that. And you have to understand, it's a solid rocket motor. So to gimbal it, basically gimbal the nozzle, you're gonna need a lot of energy specifically. Now the system is directly taken from an ICBM. So we're not going to use the ICBM grade navigation system, because that's too expensive. So we're going to use what you call electromechanical actuators. Basically, you must have seen Falcon 9s or Raptors and engines and all that jazz. They have hydraulic systems. Sometimes hydraulics, instead of using hydraulic fluid, they use kerosene if the rocket is running on that. So you can understand those systems time tested, they work. The problem is they are not only heavy, they are also very expensive, and solid rocket motors do not have that kind of leverage. Liquid is far more energy dense, so solid systems generally rely on something else. So something else is, in this scenario, is electromagnetic accelerator. Now this is a brushless motor that is driving a shaft that is going up and down, and is going to give you control over the nozzle. And this is a very powerful, boys. You can understand the voltage is around 180 volts at 100 ampere. So this puppy is powerful one, 18 kilowatt kind of power. So that's the basically how the heck the rocket is built, how the heck it's gonna be gimbling. And then you have to understand the fourth stage, basically, which is the only liquid stage in this, is gonna use hypergolic fluids to actually do the fine tuning, rotating the satellites and all that jazz. Then the structures of that, again, you can't just use sheet metal, you have to have some structure to that. So to add that structural rigidity, it's going to be iso grid milled. Now iso grids are look something like this. Now it may look like a fancy thing, but it is the best way to have maximum basically strength, rigidity, and minimum weight. Because you have to understand, rocket is not just like, okay, it's a weight. We can easily do that with a basically thin wall tube. Problem is, the rocket shakes like there is no tomorrow. To make sure that like shaking can handle, that is why you need this kind of structure. And there are places in India or even abroad. Basically in India there is Bangalore. In that Bangalore there is a highway, HAL highway, and in that highway there is a museum. In that museum you can see one completely intact fairing. It was not used, or it was scrapped for some other reason. That fairing is there. And inside that fairing, this mill diagram is there. Like, once you see it with your own eyes, you will understand why the heck it is the way it is. So, and it's gonna allow for multiple payload accommodation. That is why the diameter was selected for to be that huge. So imagine it this way. Let's say you want to launch 100 cube satellites. It's not that you're just gonna launch 100 CubeSats. You have to figure out how the heck you're gonna launch the CubeSats. You have to have a spring mechanism to throw them away. And again, the spring mechanism is gonna also take up space. So what if you have 20, 30 of launching mechanism? Then you randomly realize like you are running out of space. That is why the 2.1 diameter was selected. They needed space not for weight reasons. They needed the space for launching mechanism. Basically, they can have multiple basically layers where they're gonna have like CubeSats here, CubeSats below, CubeSats on top, and each CubeSats will have its own dedicated spring launcher system. And the first demo mission of this supposed to happen in April 2020, so quite soon, so to say. Now I talked about competition, so you have to understand China is also making it, but right now I do not know exact details whether it's going to be launched for public consumption or not, aka like commercial market or not. It will be maybe only limited to China's own private companies. So I'm not counting them yet because they are also not done yet. So we are talking about Rocket Labs. Why? Because they were the first company, as far as I know, they directly jumped into this one. They're like, we're gonna only focus on small rocket satellites. Basically, they're not aiming for Falcon 9, they're not aiming for Falcon Heavy, they're not aiming for Saturn 5. They're like, I'm gonna make a basically big sounding rocket. That's the whole point. Now they have already made it successful with this, and their sun synchronous orbit capability is around 225 kilograms compared to 300. So ISRO is a bit bigger, beefier. Now their cost is around $6 million, simply because they use complicated things, including carbon fiber. So the $6 million compared to $4.2 million, and their diameter is small. Again, you can see there is a dude, and it's a 1.2 meters. So it's kind of small rocket. However, you have to understand this. While ISRO is building this rocket, they people have already made it, launched it. They have 10 successful launches under their belt. So they are time tested. On top of that, because it's a completely novel way, they also figured out a different way to reuse the rocket. Because the rocket is so small, does not have enough delta V margin where they're going to use propulsive landing. So what they're going to do is utilize parachute. Because the rocket is small, lightweight, parachutes is viable option. And the idea is it's going to enter the atmosphere, use the parachute to slow down, and then the helicopter is going to catch it. And all of that is possible simply because this is lightweight. So if they figure that out, like, because they have done the testing, they have deployed the parachute, but right now they haven't captured it. They didn't want to. It was like first testing mission whether the parachute actually slows down enough, what kind of speeds we are talking about. So demo mission of that was done, but that's their end game. In let's say 2-3 more launches, they want to reuse something. So if they figure that out, they can reduce the price drastically. You are talking about like 20-30% price reduction. At that point, they will be competitive to SSLV. But they are more or less same as ISRO's system, not too much different, not too much faster, not too much cheaper. So they are like, same kind of thing. However, there is this new competitor that's just recently come into the show. Basically they were working in the background, but they were working for DARPA launch challenge. DARPA has multiple challenges and you can compete in those challenges. So there were 3 competitors for this challenge, DARPA launch challenge, and one of them went bankrupt, another one left, and this puppy is the only one that survived. So this is Astra's rocket. Now this is the 3rd rocket they are building. This is one of 3. Now, the main goal of DARPA's challenge was like DARPA has access to ULA. So if they want to launch a big heavy satellite, they're like, I got this. Problem is they want to launch something quick. It's like some conflict happens. It's like, dude, I need satellite there right now. So that's their end game. They want to have like, okay, build a satellite, launch the satellite, and they want to shrink it down in less than a month. So the main Department of Defense launch was not too drastic, like 1 month launch time, not too drastic. However, they must have the ability to relaunch in few days. That was the main goal. So basically, once you launch the rocket, the second rocket launch should be very quick. Now that's what this company is trying to do, and so far they are quite close to success, simply because they wanted to launch it, and the launch supposed to happen on 2 March. That was delayed simply because of the weather. So they come this close to actually launching it. Now the interesting part of this is more or less the same as electron rocket size wise and all that jazz. It's just a bit underpowered, simply because it has 5 engines in the first stage rather than 9 liquid engines, and they're both running on basically electric pump fed systems. Everything is same. However, you have to understand that this puppy fits inside a shipping container. The whole idea with DARPA was like, I want you to launch the rocket, but I can tell you when the launch inclination afterwards. Basically, like the rocket is ongoing, then you will not tell where you want to put it. So again, that's drastic, but the reality was like they wanted the ability to shift the launch site. Basically, instead of, let's say, launch in Mexico, then launch in some other place, or launch in Alaska, things like that. They wanted that ability. To achieve that ability, everything in this system was designed in such a way that it can fit inside a container ship. So they have one container ship which is just a launch pad, another container ship which has the rocket, another container ship which has all the supporting mechanism. So the idea is they're gonna have one cargo plane and fit all 3 container ships inside, and done, like the end. Like you want to launch it, you point us to the nearest runway, and they have successfully did all that, like everything, every testing and all that, test firings and all that. They have tried to launch it 2 times. That is why this is one of 3. Both of them failed, but that was expected. Like nobody expects first rocket to go well, but they are very close to actually launching. And their price, now that's the most scary part about them, their price is around $250,000, not $1 million, not $4 million, not $6 million, $250,000. That is $250,000. That's way too low. That's like nothing. That's like in Indian rupees, that's 2 crore. Like there are people who spend that kind of money on, like, just YOLOing around. So that amount of like price reduction is quite amazing. And they don't have to do recycling, because again, they specified like they are making from the nose cone, they are making from a cheap sheet metal rather than, like, carbon fiber. Why? Simply because the carbon fiber will cost more than the rocket. So these two competitors are very serious threat to SSLV. Now, again, what will happen when rocket actually launches? Nobody knows, simply because maybe that exact fact that it has giant fairings and you can pack a much bigger satellites, or you can have much complicated launch sequence for hundreds of such small satellites, that could play a very crucial role. Or these people may find out, like, recycling rocket does not reduce that much price, and they have to figure out the fuel cost of the helicopter, because helicopter has to catch it mid-air. If it lands in this, touches the seawater, it's dead. So again, there is a lot of implication here. So the upcoming race for small satellite launch markets is going to be very interesting. So this was my presentation on ISRO's small satellite launch vehicle. I hope you liked it and learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.